Hi, and welcome to this lecture on sustainable development, materials and circular economy. My name is Jon-Erik Dahlin. In our modern society, we use enormous quantities of physical materials, such as metals, minerals, plastics, ceramics, glass, composites, and so on. Our modern society is entirely dependent on the supply of a huge number of different elements and specific and very often very complex compounds of elements. Some of them are found in almost unlimited quantities, whereas the supply of some materials is very limited. We have grown used to a constant supply of many of the modern gadgets, which today have become an integrated part of our lives. Anything from mobile phones and computers to things we do not always realize are there, but that are active in the background, such as power plants, base stations for mobile communication, satellites, and so on. You could say that at this very moment, from a historical perspective, we find ourselves weighing between two paradigms called the linear resource economy and the circular economy. Earlier, the production of all these physical units that we use for a decent and comfortable living and the materials they are made of has taken place in accordance with a linear logic. We have taken the materials out of the ground and reshaped them and reassembled them into products that we want to use. When done using the products, they have been disposed of. And recirculation of the stuff they are made of hasn't been used to any significant extent. The result of the linear logic is partly that some of the materials we use have become hard to produce in the quantities they are being utilized, and partly an expansion of waste dumps and landfills. This isn't going to work for much longer. Today, therefore, different forms of recycling within a growing number of areas are introduced. Many are of the opinion that the economical model that our society rests on has to be adjusted, and we speak about a transition from a linear material economy to a circular economy, in which products and materials are reused and recycled. The supply of some of the raw materials that we use on a daily basis is presently becoming scarce. One reason for this is that we use more and more complex combinations of elements. As we learn more about how nature works, we discover that we can make our products increasingly effective and better adapted to their functions, which of course is a good thing. But this also means that we are creating a bottleneck in the production chain. A good example to illustrate this is the development of computer chips, also called integrated circuits. In the 1980s, the computer chips were manufactured from a palette of 12 elements. A decade later, 16 different elements were used. And today as many as 60 different minerals or their components can be used in the manufacturing of modern integrated circuits. These offer a high calculation speed and a high capacity. But more and more complex computer chips contribute to Moore's law and give us access to better electronic products, which of course in many ways can be used as a contribution to sustainable development. A secure and safe management of all these elements has become crucial for our modern technology to function. There are a few materials that today are considered critical in the sense that their availability risks to become reduced in relation to demand. And this is of considerable financial significance. The European Union has defined some 20 materials which are critical for our welfare and our society. Some of these materials also play an important role with the so-called clean tech or clean technology that can contribute to a sustainable development. A few examples are dysprosium, neodymium and praseodymium, which all belong to the rare earth metal group. They have specific magnetic, electric, chemical and optical properties, which among other things make them useful as lightweight magnets for wind power or the manufacture of efficient batteries for the growing fleet of electrical cars. Other examples are gallium and germanium, which are important in the manufacture of high-efficient solar cells, within semiconductor electronics, and in the manufacturing of low-energy lamps. Many aspects may combine to make a material critical. There can be a physical limit to how much we can produce of the material, simply because there is a limited amount of it in nature. Here we can compare with the discussion in oil production, where we often hear about the so-called peak in production called peak oil. Similarly, we can reach a peaked production for any commodity when the increasing demand no longer can be met by an increased production. And this leads to heavy price increases. And this can occur rather quickly. But the reduction of the known raw material reserves can also influence supply and price without necessarily leading to a drastic production peak. And sometimes even inefficient pricing mechanisms can lead to a material becoming critical. For instance, if the price of the material isn't changed to reflect supply or cost of production. This can happen due to different types of governmental interventions, such as subventions and fees, if those are imposed in a way that interferes with the natural market dynamics. Certain materials becoming critical can have many unwanted and sometimes unexpected effects. The most obvious unwanted effect is, of course, that the price of these materials may rise, which leads to a price increase of the products in which they are used. It can become particularly harmful if the price alternates heavily or quickly. This can lead to the market not being able to adapt, which will result in cascading effects. Another effect could be that materials that are in very high demand are used by criminal organizations in dictatorial regimes if the supply of materials is located in the areas controlled by them. This image is from a mine in the Ituri region in the northeastern part of Congo-Kinshasa. The United Nations has inaugurated a number of resolutions with the aim to make it harder to do business with so-called conflict minerals. And bigger companies can also, as part of their sustainability reporting, show what measures they have taken to avoid involvement in this type of business. Many of the critical materials and critical minerals also entail considerable health hazards for those involved in the excavation and the refinement, and those involved in the refinement. Mines and refinement plants may, on top of that, have considerable environmental effects. So, ironically, in many places, the excavation of many of the minerals needed for solar and wind power contributes to the dispersion of poisonous and radioactive materials in the nature and to expose people to considerable health hazards. The World Health Organization, WHO, today anticipates that solar energy statistically is 5 times more deadly than nuclear power per produced kilowatt hour. That is still 200 times safer than coal power, which is the biggest energy-related environmental and health issue today, but still remarkable. So what steps do we need to take in order to move from a linear economy to a circular? This chart from the Ellen MacArthur Foundation shows a few steps. First, in the linear economy, the raw materials are extracted from the nature. In the series of refinement steps, we assemble elements and minerals into components and eventually into products that will be beneficial for users and consumers. When we are done using the products, they are discarded of. If you can extract energy from them, burning them in incinerators with a combined power and heating plant for heat and electricity production, this should be done. And what cannot be burned is transferred to a landfill. This is how it usually works today. Raw materials can be either renewable or finite. The renewable ones derive in one way or the other from Earth's biosphere, whereas the finite ones derive from geological layers, many times located under the ground. To make our resource economy somewhat more circular, it is necessary to recirculate a major part of the materials we use. Preferably all materials, of course, even though that's considered a utopia by most people. It's most efficient to recirculate the material as high up the value chain as possible, preferably mending products as far as possible instead of discarding them. After a user is done using the product, you can investigate if it can be reused by someone else. Today, new markets emerge where products are co-utilized by several users, the so-called sharing economy. When a product eventually can't be reused any longer, we can try to recycle its components. Today, it's oftentimes hard to do that because the components are very intimately assembled. The material recycling could, however, be made a lot easier if we already in the design phase kept recycling in mind, and this is called eco-design. In terms of renewable resources, they are already included in the circular cycle today, but to make the cycle greener, a lot more needs to be done. In a circular economy, we would utilize the biological and chemical production much more efficiently than we do today. The recycling of components and materials can be done in a lot of different ways, and it is important that we introduce processes for how recycling is performed that at the same time is environmentally and health friendly. This image comes from an electronic waste or e-waste recycling station in Agbogbloshie, a suburb of Accra in Ghana. The smoke from burning electronic scrap lies heavy over the area. To crush and separate discarded computers and mobile phones to get access to valuable components and recycle them is demanding and offers little pay. In Ghana and other places in Africa, cheap labor is available and the work is carried out without the least regard to environmental or health aspects in many cases. Just as with conflict minerals, the international community has taken action to regulate the trade with e-waste, but this management is still a problem. It's important to point out not only how recycling is conducted, it's equally important that the infrastructure and the plants for recycling are in place and how they are functioning. Before a product is manufactured, several things can be considered as how to reduce the negative sustainability impact. In so-called eco-design, all parts of the product's life cycle are taken into account. This means, for example, to choose materials which, to the greatest extent possible, are non-critical, that have a minimum impact on the environment and health, and are easy to recycle. It helps if the product is easy to disassemble, like this phone from Fairphone, where all components can be replaced. In addition, one tries to choose materials, manufacturing processes, and distribution channels with a minimum of energy usage and ecological footprint. Another important detail to consider is that the product, when in use, has a minimum or even negative effects on the environment, has a minimum of negative effects on the environment and on health. For some products, it may involve using more sophisticated materials that weigh less and are more energy efficient or have other properties that are positive in the product's user phase. Ultimately, all manufacturing in some way or another may deal with creating products that contribute to people's lives in a positive way. it may be useful to stop for a moment and think about different values or financial capital which must be invested to manufacture a product, and how to do that with a minimum of environmental and health impacts. The two most obvious types of capital are human capital, which is human work and knowledge, and manufactured capital, which is machines, buildings, infrastructure, and so on. These two types of input capital are normally included in the financial calculus of the production process. Added with raw materials, they are assigned to manufacture the products that consumers and users ultimately are demanding. But there are also two other types of capital that must be added, even though it is not always done by the producing company. Those are social capital, which is the value that the society provides, such as skilled labor, laws, norms, regulations, and so on. Without them, it would be impossible to produce. And also natural capital. The concept natural capital is in itself very complex, but it includes the values that nature provides, such as access to raw materials and an environment that enables and contributes to the production. More about natural capital in a while. For now, we can state that if all four types of capital are combined, we have created the conditions for producing physical products that can contribute to human welfare. Natural capital is applied through something called ecosystem services, which can be understood as products and services that nature's ecosystems provide to us humans. And those include, for example, such commodities as crops, fish, and wood, all produced by the biosphere, but also services such as water cleaning, climate regulation, and pollination of plants. We humans benefit either directly, like when plants produce oxygen, or through effort, such as when we are farming. Natural capital is a broad concept that includes a number of different aspects. Therefore, it can be seen as a capital found in nature or produced by nature, which can be measured and given a monetary value. Natural resources form one part of nature's capital. Of finite resources like metals and fossil fuels, and renewable resources such as growing forests and fish in the sea. When we take from natural resources and convert them to something else in our economy, we use the natural capital and exchange its value for another value. There are also other types of environmental assets, such as land and water. And we have already mentioned the ecosystem services, and they can be said to be the channel that different natural capitals pass through to contribute value to the human economy. Biodiversity is also natural capital that can render monetary value. Biodiversity means the diversity in genetic variation in species and individuals. Biodiversity plays a fundamental role in the functioning of ecosystems and can also be seen as nature's own insurance, which helps ecosystems to adapt to external influences such as shocks or stress, climate change or disease. In this lecture, we have looked at the use of different physical materials that we convert to products that contribute to livelihood, safety, and well-being for people. Many of the products that have become everyday goods contain substances and materials or combinations that are critical, unusual, hazardous to the environment or health, or that contributes support for parties in armed conflicts. There is a lot we can do to make the management of modern materials more sustainable. For example, increasing the elements of eco-design in the manufacturing process, and begin to take steps to make resource economy less linear and more circular.